Hi and welcome to another very exciting tutorial. Today's video is about advanced animations with UIViewPropertyAnimator, which we're going to use to create this cool looking effect, which is totally interactive and really nice. But let me first of all tell you that this video is brought to you by appmatch.com, and appmatch.com is a new service that uses quizzes and artificial intelligence to match you with the apps that you should be using. Just go to appmatch.com with your mobile phone, pick a quiz and answer some questions, and then you get really cool matches. And the more the system learns about you, the better these matches get. And all apps in their ecosystem have been tested and vetted by the AppMatch team. And as a developer, you definitely want your app recommended here on appmatch.com, and you can just go to appmatch.com/developers to submit your app, and you will find a link to the AppMatch service in the video description below. And also in the video description below, you will find some start files that we're going to use to create our cool looking animation here. Just go ahead and download these start files and open up the associated Xcode project. And I'm going to show you what I already created so that we can concentrate on UIViewPropertyAnimator in this video. And at the moment we are looking at the main storyboard, which only consists of a image view, which is holding a photo at the moment. This also could be a totally custom UI view, even a view controller. If you're using UI view controller animated transitioning, you could use a view controller with that technique that I'm going to show you now. And also we have a dark view, which we are going to use to darken the background, which is in our case just a screenshot of a website. So this is what we're going to use, and these are the components. I'm setting the alpha value of this dark view now to 0 so that we can see the background user interface, and this means that we have this image view in the background. On top of that image view we have a dark view, and on top of that dark view we have our image that we'd like to animate using a pan gesture. And this means we're now heading over to our view controller, and I'm going to show you some of the code that I've already added. First of all, we have an enumeration for our two animation states. We have a full screen state and we have a thumbnail state, and these two cases are just stored in this enumeration. Then we have an outlet for our photo view. We have an animator property, which is an object of the type UIViewPropertyAnimator, and we have the current state as a property, which is of type animationState. We are storing the current thumbnail frame in a property, and we have a global property for our pan gesture recognizer so that we can deactivate it or enable or disable it if we have to. So these are all the properties that we are going to use. And in addition, of course, we have the dark view, which I'm going to cut and add that right below the other IB outlet so that we have that sorted in the right positions. And then we have our viewDidLoad function, which of course calls super viewDidLoad. And here is the place where we initialize our pan gesture recognizer with a target of self. And if the pan gesture recognizer is triggered, then we're calling the handle pan function, which I've also added right below here. This receives a recognizer parameter, which we are going to work with in a second, and then we're adding this pan gesture recognizer to our photo view so that pan gestures on our photo view are recognized. And we have our thumbnail frame that we are just storing in that property. And since we're starting our application with a state of thumbnail, so our photo view is in the state thumbnail, and we're indicating that by assigning thumbnail to the current state. And what we're doing here in handle pan is to go through the state property of the UI pan gesture recognizer parameter here. And we have different states. For example, we have began, we have changed. So this is when we're beginning our pan gesture. This is when we're moving our finger, and ended is if we are lifting our finger from the display. And depending on what we are doing here, we need to trigger different things. So let's start with the began state of our recognizer, of our pen gesture recognizer. And what I'd like to do for that is adding a function for our began state, which I'm calling start panning. And in this function, what we'd like to do is deciding if we are actually in full screen and we want to go into a thumbnail state, or if we are in a thumbnail state and go into a full screen state. And depending on that, we like to choose a different animation, or we like to configure our animation differently. So what we are going to start with is, first of all, a final frame variable, which is going to be a CG rect. And I also need to initialize that here because we are going to access it in a closure, and then it needs to be initialized before we can use it. And what we also like to do here is using a switch state and switching through the current state, which is a global property that we use to decide if we are indeed in a state of full screen or if we are in a state of thumbnail. And these are our two states that we need to deal with. And if we have another state, then we can actually print that we are in an unknown state, but we shouldn't actually see that message in the console. But now that we have our two cases, we need to think about what we actually want to do here. So first of all, let's say that if we are currently in the full screen state, then our final frame should be the thumbnail frame. And if we are currently in the thumbnail state, then our final frame should be the size of our screen. So what I'd like to do here is just assign self.view and its frame. And with that, we have the whole screen as the final frame. Now we know that our final frame variable was written to but never read, but this is something that we're going to change now. And for the first time, we're now going to access our UIViewPropertyAnimator. And this UIViewPropertyAnimator is really cool, so I'm going to access it right now and initialize it now with UIViewPropertyAnimator. And we can initialize that with different initializers. For example, we can control the timing curves with custom control points. We can use preset curves like ease in, ease out, and we can use an initializer with a damping ratio to decide if we want to have critically damped spring animations or underdamped spring animations. And this is what we are going to do in this video. So we are going to decide what actual duration we want to have for our animation. I'm going with 1 second here, and I want an underdamped spring animation, which will give me a slight oscillation at the end of my animation. So I'm going with 0.8 here. And now we're defining our animations block, and we actually decide what we'd like to do. And this is now very similar to a standard UIViewKit animation if you're using UIViewAnimate with duration and so on. So all I need to do is using self, my photo view, and the frame, and assigning my final frame variable here. And with that, we decide how this animation should work. And now the cool thing about these UIViewPropertyAnimators is that we can actually scrub through this animation, and we do not need to kick that off right away. And we can also have different completion blocks for this animation. But let's just have a quick look at our handle pen function, where we will replace our print with pen started now with start panning with our function that we have just created. So this was the first part. We're going to make some changes to that function later on to also use our dark view. But now let's move to the next function, which is now very cool because it is going to be responsible for the scrubbing part. So now we can actually start our animation, but we're actually scrubbing through this animation if we're using our finger to move it up and down. And this is like scrubbing on a timeline, and we're going to do that right now with a new function that, let's just call that scrub. And for that scrub, we're going to use one parameter that I'm going to call translation, which should be a CG point. And for that translation, we actually need to access the translation coming from our recognizer. So let's scroll up a little and we're going to reuse that. So I'm going to add a constant above our switch statement that I'm going to call translation. And we're getting that from our recognizer and the translation function. And we want that from the self and the view and its super view, which should be the root view of our application now. And we're then calling our new function scrub in the changed case. So I'm just calling scrub and passing along the translation that we have just received from our recognizer. And then we can scroll down again back into the scrub function. And since we're going to work with our animator, we should first of all check if our animator is available using an if-let statement. So animator and assigning self animator. And if that works, we can continue. And the first thing that we'd like to do in order for us to calculate the progress for our animation, we need to get a correct translation. And for that, I'm using the center of the screen so that this feels really natural. So I'm using a new constant, calling it yTranslation, and using self, view, center, and y, and we're adding the translation from our parameter and its y component. And now we need a progress variable that we're going to change depending on the current state of our animation. It could be from thumbnail to full screen or from full screen to thumbnail. So let's use progress, which is going to be a CG float. And I'm going to initialize it with 0 here. And then we're switching through the current state, and we can actually copy that switch statement from the start panning function. So I'm just adding that here, and I'm going to maybe reverse that. So thumbnail first, full screen second. All right. So now we have our switch statement, and what I'd like to do now is calculate the progress for our animation, and then we can assign this progress to the animation's fraction complete property. I'm going to show you that in a second, and with that we get this nice effect, actually depending on the current position of your finger. So let's go back here and accessing the progress variable. And here, if we are going from thumbnail to full screen, our progress is 1 or 100% of our screen, and we subtract the fraction of our y translation divided by self, view, center, and y. And with that, we have the progress for the state if we're moving from thumbnail to full screen. But what if we are in full screen and we go to our thumbnail size? Then we actually just need to turn that around and use the fraction of our y translation, divide that by self, view, center, and y, and subtract 1. So this gives us the progress for both our states, and again the default state is actually an unknown state, and we shouldn't see that too often. But now what if our progress is indeed 100% or 1, or it is 0? So let's just have a quick look at the UIViewPropertyAnimator documentation, and as you can see, the UIViewPropertyAnimator is a class that animates changes to views and allows the dynamic modification of those animations, and that is exactly what we're doing at the moment. But let's have a look at how these animations behave. And as you can see, we have an inactive, we have a stopped, and a active state for our animations. And next we are going to make sure that our progress never hits 0 or 1. So it always should stay between 0 and 1, and this is important because whenever it reaches 1, it will set as completed and its status will change again. We do not want this. And after that, we're going to access the fraction complete property, and this is the completion percentage of the animation, and we are going to change that depending on our current progress. So let's go back into our scrub code, and what we want to do now is using the progress and make sure that we never reach 0 or 1. And we're doing that using the max function, for example, and use one value that is very close to 0. So let's say 0.0001. And we're using the min function for the second comparable value. And here we use a value that is pretty close to 1. So let's say 0.9999 and compare that with progress. So in that way, if we had a value of 0.5, for example, for our progress, we would get the minimum of those two values, which would be 0.5, and this would be greater than 0.0001, and with that we had the progress value. But if we are very close to 1, for example, if progress would be 1, then we would choose the minimum, which is very close, but not yet 1, and we would choose that, and in comparison to 0.0001, we would still choose a value that is very close to 1. Just think about that for a second, and then you will see that we will always get the correct value, but never a value that reaches 0 or 1. So with that progress now calculated, what we can do is using our animator again, that we haven't used before, and access the fraction complete function and assign our current progress. And let's just quickly build that and make sure that we have called our scrub function, and then we can actually give this a try and see if we can actually move around our photo for the first time. And as you can see, this really already works and is really cool, but we can't really do anything after we have moved it around, and this is because our pan ended, and our animation doesn't know what to do when the pan ended. So let's also handle that case by adding yet another function, which I'm going to call end animation, with a translation, which is again a CG point, and we're also going to need a velocity for this end of for the ending of our animation, because we'd like to get a spring timing parameter for the end depending on the velocity of our photo view so that it feels more natural. So we also will have a velocity parameter here, which is also a CG point, and we will later use the Y component to create a vector for the velocity. And to create that vector, I'm going to use a vector object, initializing it with CG vector. And now we're using the velocity and its X component for the DX value, but let's divide that by 100 to create a smaller value here first. And let's do the same thing for the Y velocity as well, having now the two components for our vector. And now let's also create some spring parameters with this vector using our vector as an initial velocity. And I'm going to initialize that with UI spring timing parameters. We're going to use that to add that to our animator in a second. And I'm initializing that with a damping ratio again and an initial velocity. And I want an underdamped spring animation, so I'm adding 0.8 as I did with my original animator already. And we're getting this nice oscillation then. And for the initial velocity, we're just using our vector. And now, so that the animation really ends, what we need to do is using our animator and call the continue animation with timing parameters and a duration factor. So let's just call that function here. And my timing parameter is my spring parameter here, or my spring parameters, just copying that here. And the duration factor in our case is going to be 1. And before we can test that in the simulator, we need to call our end animation function in the handle pan function. And here again, we're going to remove the print statement for pan ended. And first of all, we need a velocity. So let's add that velocity object right here. And we're getting that from our recognizer again, using the velocity function. And we want to use self, view, and its super view to get the velocity, and then we can call the end animation function using the translation that we already got and the velocity factor right here, velocity I misspelled that, velocity. All right, so let's pass that along and build that really quickly and run it in the simulator. And then we should be able to see something. So let's do that. And the animation already is really cool, but as you can see, we cannot reverse it. And we need to make some last modifications to our end animation function to be able to actually reverse and play around with our animation. And therefore, we're going to add an if-lat statement and check if we can actually access our animator. So if-lat animator equals to self animator. And then we will also cut the code we wrote so far in the end animation function, paste that into that if statement, and add some more logic for that. And first of all, we need to check again in which state we actually are. Are we in a thumbnail state or in a full screen state? And therefore, I'm copying again our switch statement. And now let's just see that we remove the code that we wrote so far. And now our mission is actually to check if the finger already crossed more than a third of the screen, and check if we actually want to reverse our animation based on the current state, or also adding a completion block to our animator to make sure that our current state property is always up to date. So for that, we're using an if statement, checking the current translation and its Y component. This is the only thing we're interested in. And first of all, we're checking that for the thumbnail state. So if our Y component is less than or equal to negative screen height, the negative screen height, we get that with self view frame size and height. And actually, we're going to need that a couple of times. So let me just copy that. Check to have a screen height object here, using that again right there. And now we have a screen height property that we can compare. And if our translation is less than or equal to negative screen height divided by 3, and this is important because now we're moving our finger from the bottom to the top, which gives us a negative value, or if our velocity and its Y component is less than or equal to minus or negative 100, then our finger moves so fast that we actually want to complete our animation, or that we know that our animation is actually complete. And in that case, what we want to do is, using our animator, change its is reversed property to false, and also use the animator and add a completion handler right here. And the completion handler gets one parameter, which is the current position, which we are not going to use, but just so that you have seen it, it's UIViewAnimating position. And here in the completion block, what we need to do is, using self, the current state, and set this now to full screen. And also what we should do is reactivating a pen gesture recognizer after we have deactivated it when we lifted the finger, so that we do not get unexpected behavior. So let's quickly do that in our end animation function here, and use the pen gesture recognizer right after the start of the function, and change its is enabled property to false, so actually disabling it. And if our animation is complete, we know that when the completion handler is called, we can use self, our pen gesture recognizer, and its is enabled function, and set this to true again, so that we can change our photo view size again with our nice animation. So, and in any other case, in our thumbnail state, we'd like to do something very similar. We'd like to use the is reversed function, but this time set it to true, and also make sure that now that we are actually moving our finger from the top to the bottom, our current state is going to become thumbnail, no longer full screen, and this also means that our animation is indeed reversed, but our pen gesture recognizer can still be activated. And now for our full screen case, we can actually just copy all that code again, paste it right here. And now in that case, we need to check if we are in full screen and our translation is, and its Y component is greater or equal to the positive screen height divided by 3, because now we're moving the finger downwards, and again we're using a third of the screen to indicate that a completion is imminent. And we're now, of course, also using a positive value for the velocity. And all that is left to change now is the current state, because now we're actually moving from full screen to thumbnail in that case. So thumbnail here and full screen in the else statement. Now let's just quickly build that, see what's wrong here. We need to remove the question mark because this is no longer an optional. Let's build that one more time, and the build succeeded. And now we can actually have a look at our animation already before we will add one last finishing touch to it. And as you can see, we can flick it, and this is really nice. We can interactively move that around. Pretty cool already. So this is a very nice animation. And now what's missing is actually that our background darkens as we move upwards. And how can we change that? It is very, very simple to do that. We just need to go into our start panning function. And if you remember, we have a dark view that has an alpha value of 0 at the moment. And all we want to do now is changing that alpha value. So in addition to our final frame variable here, we're also going to use a dark view alpha value, which is going to be a CG float, and I'm initializing that with 0. And if we are in full screen and we're moving to thumbnail, then what we want to do is setting a dark view alpha value to 0. But if we're moving from a thumbnail to a full screen, then we're using the dark view alpha and set this to 1. And now all we need to do to achieve this effect is going into our animator's UIViewPropertyAnimator initialization and its animations block and access self dark view alpha property and set this to dark view alpha. Let's initialize that in the simulator. Let's run this in the simulator and see if we get this effect. And now I'm moving upwards, and as you can see, it gets darker the more we reach the top, and this is really, really cool. So I hope you enjoyed this animation tutorial. UIViewPropertyAnimator is really a cool new addition to UIViewKit animations, keyframe animations, and so on. And thank you so much for watching, and I'll see you in the next one.